Hello dear students, my name is Vikram Nallavade. I am an assistant professor in the Department of Mechanical Engineering. I am working at SATCOE, Yadra Isalkanji. Today we'll discuss subject automobile engineering, in which we'll start the unit number 2, that is the steering system. So let's start today's lecture with the content of this presentation, in which we will cover objective, introduction to steering system, and steering geometry. So let's start with the objective. Objective of today's lecture is to understand the steering system and its geometry. So first of all, let's start with what is steering system. So here this slide represents the steering system. Generally, this picture represents how steering wheel is used to provide the angular motion which is obtained from the rotary motion of the steering wheel. As it is mentioned, the steering system is an assembly of linkages that are used to provide directional control to the vehicle. Steering system includes some important units, as it is represented in the diagram. First unit that is important is steering wheel, which is controlled by the driver. Then important part of steering system is the steering gear, which increases the mechanical advantage and converts rotary motion of the steering wheel into straight line motion that moves the steering linkages. And the third important unit of the steering system, these are the linkages, so which transmit the steering gear movement to the front wheels for their proper alignment. Generally, all vehicles use front wheel steering, whether or not they drive is the front wheels, and irrespective of engine position. The steering system, in connection with the suspension system, greatly affects the directional stability at higher speeds, particularly for rear wheel driven vehicles. So this is all about basics of steering system. We will discuss various functions of the steering system. So two various functions we will discuss: primary function and the secondary function. So in the primary function, the primary function of the steering system is to achieve angular motion of the front wheels to negotiate a turn. As it is mentioned in this diagram, this rotary motion of the steering wheel is here helpful to negotiate a turn. That is the primary function of the steering system. Then this is done through the linkages and the steering gear, which convert the rotary motion of the steering wheel into the angular motion of the front road wheels. Then some of the important secondary functions are also mentioned, that to provide directional stability of a vehicle when going straight ahead. That is also very important, that direction is controlled by the steering system. Then it is to provide the perfect steering conditions. Now why perfect? Because perfect rolling motion of the road wheels at all times, so it should not affect the steering mechanism. Then to facilitate straight ahead recovery after completing a turn. That is also very important point, that after taking a corner turn, when it goes to stabilize, that also stables the motion of the vehicle in the straight direction. Then very important here is to minimize the tire wear. This is also very important function of the steering system. So what are the various requirements of the steering system? First requirement, we will consider the steering mechanism should be very accurate and easy to handle. Then the effort required to steer, that should be very minimum, and it must not be tiresome to the driver. Means sometimes drivers take a long drive, and during that the effort should be very lesser, and it should not affect the nature of the driver by being tired. So that should be considered as a requirement of the steering system. Then the steering mechanism should also provide directional stability. This implies that the vehicle should have a tendency to return to its straight ahead position after turning. Means after taking a turn, the steering position should be as it was in earlier condition. So now we have to discuss the steering geometry. In steering geometry, various points we will discuss. So let's start with the camber angle. So as the position of the car is shown in this slide, you just observe the positions of the wheels, how these are on the road surface, these are straight or these are in some angles. So these positioning of the wheels onto the road, these are termed as the camber angle. Generally, camber is the inward or outward tilt of the wheel with respect to vertical, as seen from the front of the vehicle. So whatever the angles are made when it is observed from the front side, in that manner camber can be termed. The camber is taken to be positive when wheels tilt outward. So it is shown in the next slide. So this is the camber, and it is termed in positive camber when the wheels are tilted outside from the vertical axis. The yellow line shows the vertical axis, and these green lines shows the camber when the wheels are tilted in the outside direction. So camber is the tilt of the car wheels from the vertical, and it is also called wheel rake. And then camber angle is usually 2 to 3 degrees, and it is exact amount is specified. Its exact amount is specified taking into account the kingpin inclination. That point we'll discuss. Due to unequal length of the control arms of the suspension system, the camber goes negative when the tire hits a bump and moves up, and it is positive when the tire drops into the hole. Now in next slide we will discuss that we have already discussed that camber is positive if the tilt is outward at the top. Steering wheel returns after completing the turn, that we discuss in the requirement section. That is, increases the straight edge stability. This means increase of turning effort required at steering wheel. Now let's discuss about the zero camber. When the angle of the camber is zero, means tire as well as the vertical axis, these are on same line. Then here it shows the road normal axis, the camber angle is 0. It is always desirable that tires should roll on ground vertically so that wear is uniform. In next slide as we have discussed positive camber, if the wheel is tilted in outward direction, but here in this position it is shown that the wheels are tilted inwards, tilted inwards. So the angle made between the axis of the wheel as well as the vertical axis, that is the negative camber angle. Uh, we have already discussed camber should not increase more than 2 degrees, as the limitations are 2 to 3 degrees only. So camber is negative if tilt is inward at the top. If while running tires are inclined from vertical, either inward or outward, they will veer more on one side than the other. Means if we are talking about a positive camber or negative camber, in which the veer is maximum, but in case of zero camber, the veer is very lesser as compared to positive and negative camber angle. Here it resists the tendency of wheel to slip sideways during the cornering, but also increases the steering effort. Okay, now we will discuss next point, that is caster angle. So this is also very important as like camber angle. So in camber we had discussed the positioning of the car from the front side, but in case of caster we'll see the car from side view. So here the angle between the kingpin center line or steering axis. So somewhere here it is the steering, and the steering axis is like this. So accordingly we will discuss about the cast angle. So it is the angle between the kingpin center line or steering axis and vertical is called caster angle. Or when we say the cast angle is the tilt of kingpin center line or steering axis toward the front or rear of the vehicle. The caster is positive and negative. We will discuss in the next slide. So here it shows the normal position of the wheel, and this vertical axis of the wheel is represented in this manner. Now here it shows the positive caster angle uh, if the wheel is rotating on the rear side. So in this manner, from the vertical axis and the steering axis, the angle is made is the caster angle in the positive manner. So the caster is positive when the kingpin center line passes through the road surface ahead of the center of the tire contact with the road, as shown in this picture. So in next slide, again this represents the steering axis is straight, and wheel vertical axis also meets on same line. So in previous slide we discussed the positive caster angle when rear side the wheel is moving, but in the case of negative caster angle, when the meeting point of kingpin center line lies behind the wheel center line, caster is designated as negative. It means when steering axis is tilted on the front side, then the axis which what the angle is made by the vertical axis of the wheel, then it is called negative caster angle. In today's session we discussed the camber angle, means alignment of position of the wheels from the front side, and we discussed about the caster angle when it is considered from the movement of the wheel on rear side or front side when it is observed from the side view. Thank you so much.